Welcome to Aevum's virtual unveiling of Raven X, the world's largest unmanned aerial system for rocket launch and space logistics. Everyone here at Aevum and our partners are very grateful you can be with us to help us celebrate this milestone. My name is Emily O'Brien. I'm the VP of Communications for Aevum. This day has been long awaited. Honestly, though, in talking with our CEO, Jay Skylus, a virtual unveiling isn't exactly what we had in mind. That said, we're grateful for our health and we will make the most of this opportunity. Honestly, we can probably fit more of you in with us online than we could in our hangar. You will hear from Jay here shortly, but kicking things off, it is my privilege to introduce Lieutenant Colonel Rose of the United States Space Force. Aevum is proud to have been selected as Space Force's partner for the upcoming Aslan 45 mission. Thanks, Colonel Rose.
Jay Skylus, distinguished guests, and all other space launch enthusiasts. On behalf of the U.S. Space Force's Space and Missile Systems Center and its launch enterprise, I am privileged to be a part of this milestone, the unveiling of the Aevum Ravn X autonomous launch vehicle. This is an exciting time to be talking about responsive space launch, as the need for such capability is only intensifying for our warfighters and national leaders. Responsive space launch is a game-changing capability and can enhance national security space resilience. As the threat is growing to U.S. space superiority, responsive space launch provides another key tool in our warfighter arsenal. I'm excited to see the bold innovation and responsiveness in development today by our small launch industry partners to support emerging warfighter needs. The U.S. Space Force is proactively partnering with industry to support U.S. space superiority objectives. Having a robust U.S. industry providing responsive launch capability is key to ensuring the U.S. Space Force can respond to future threats. SMC's launch enterprise continues to push responsive space launch boundaries in support of U.S. Space Force needs. Within our launch enterprise, the Small Launch and Targets Division manages the Rocket Systems Launch Program, providing launch services to the Department of Defense and other government agencies for national security operations, prototyping, and research and development requirements. Using the Small Rocket Program Orbital Acquisition Strategy, or SRPO, we selected Aevum to launch the Agile Small Launch Operational Normalizer 45 mission, otherwise known as Aslan 45. The SRPO contracting vehicle allows for the rapid and competitive acquisition of orbital launch services of less than 400 pounds and enables launch within 18 to 24 months from contract award or faster if required. We established Aslan 45 as a small business set-aside for a dedicated launch service. We used simplified acquisition procedures and oral presentations for the proposal to reduce administrative costs, avoid unnecessary burden for the contractors, and it enabled us to make the award in just over 3 months from proposal receipt. The acquisition strategy for the Small Rocket Program Orbital allows for emerging and innovative small launch providers to compete for contracts anytime during the 10-year ordering period. The SRPO strategy is just one example of contracting flexibility within the launch enterprise and is vital for the Rocket Systems Launch Program to increase competition and reduce the cost of small launch while bringing new and innovative launch solutions to meet the warfighter's need. I look forward to the Ravn X unveiling and again applaud the innovative use of commercial technology by Aevum to advance our capabilities and demonstrate responsive space launch. Congratulations to the entire Aevum team on getting to this point in Ravn X's development. To Jay Skylus and the rest of the industry and government team, thank you again for the opportunity to take part in this event. Semper Supra.
Hi everybody, my name is Jay Skylus. I'm the founder and CEO of Aevum. First of all, thank you so much for tuning in today. I'm so excited you're able to join us for our first public unveiling of the Ravn X autonomous launch vehicle. Before we move forward though, I want to tell you a little bit about myself and the company. I grew up in Alabama, and in 2005 I came across news of American soldiers who were killed in action in Afghanistan. With my own brother in the Army, this news felt personal to me. And upon doing further research, I realized that communication challenges played a key role in this particular event. Determined to figure out why, if I can so easily instant message my friends at home, why our warfighters were having issues with communications overseas. I did my research and found out that the rugged terrain of Afghanistan made it really difficult for communication technologies to work properly there. Upon further research, I realized that the technologies that can provide a solution to these things, these issues, already existed, but they just needed to be put in the right places. More specifically, they needed to be deployed to space as the ultimate vantage point for anywhere on Earth. However, the logistics barrier of deploying these assets to space was so high that it was stifling progress on the communication front. In fact, when you look further into this, not being able to deploy things readily to orbit is stifling progress on a lot of global humanitarian challenges that could be helped today by already existing technologies. And so in 2005, I resolved to make space accessible for everybody on Earth, and I never looked back. So fast forward to 2016, I founded Aevum. And at Aevum, we provide comprehensive space logistics services for lightweight, small payloads to be deployed into low Earth orbit. In fact, we're focused on any orbit below 2,000 kilometers, but nothing higher. When we talk about space access, most people are familiar with ground launch and air launch. But when I started my journey to make space accessible for everybody, I realized that ground launch and air launch had some gaps that needed to be filled to truly make space accessible for everyone. And so at Aevum, we invented a brand new paradigm of space access called autonomous launch. And autonomous launch is really, really cool, and I'm so excited to tell you more about it. But before we get to that, let's dig into the problem just a little bit deeper so that we're all on the same page. When I talk about low Earth orbit, I'm really only talking about the 2,000 kilometers just above the Earth's surface. I'm not talking about Mars, I'm not talking about another star in the universe, because these are vast distances, and space is a very, very vague term. Space for us at Aevum is just 2,000 kilometers above the Earth's surface, just above the atmosphere, so that we can escape the effects of drag and other forces of Mother Nature, so that our assets can stay in place in the ultimate vantage point for however long we need to do the job. And low Earth orbit in this particular region is extremely interesting, especially to me, because from here we can make the world a little bit better. And to me, that's what this is all about. It's all about making our lives here on Earth better by deploying things into orbit. Now, something really interesting happened with the advent of miniaturization of technologies. Satellites that used to be really big became so small that you could hold it in the palm of your hand. And what we're really talking about doing with comprehensive space logistics services is taking these tiny satellites and putting them into low Earth orbit. So we're literally moving things from point A, somewhere on Earth, to point B, somewhere in orbit, low Earth orbit, more specifically. And so when you start to look at this challenge of deploying small payloads, one might easily reason that, well, satellites got smaller, so let's make the rockets smaller. Like this one, right? Juno 1 is a small launch vehicle that we launched in 1958, and compared to what you might imagine as a rocket, which is hundreds of feet long, this one is only 70 feet, which is pretty small for a launch vehicle, and it's considered small. And so we've been doing small launch for quite some time. However, this doesn't really work for small payloads, because when you make really big things go small, a lot of things don't scale with it. For example, your components like valves and other things might not scale with it. Your sensors can only be so small. And the energy density of your propellants also don't scale with size. And last but not least, the forces of Mother Nature also don't scale with size either. And so there are a lot of challenges. An easy example that you might be able to think about to grasp this concept a little bit better is if you can imagine trying to hit a target across the room with a baseball versus a feather. A baseball is more dense and has more mass, and therefore you're going to be able to more accurately follow a trajectory to hit your target. However, when you try to throw a feather at a target, the draft in your room, due to AC or movement or other things, has a higher effect on the trajectory of the feather, which is sort of harder for you to control. It's very similar. When you scale something down, you have less inertia, and the flight perturbations of the atmosphere have a higher effect. But that's not, and therefore that's why small launch vehicles historically have a higher failure rate than, say, a larger launch vehicle. Even though statistically there needs to be more expansion on that particular point. But more importantly, when you make something go small, there are other things that don't scale either. For example, you still need all of this infrastructure. You need a launch site, and you still need a lot of people to operate these complicated machines. But there's more. When you typically think about like a launch day, and it's this exciting day where you get all this fire and there's rumble in your chest, and it's just the most exciting thing that you've seen. What you're not seeing is all the different activities that took place leading up to space operations or launch day. And all of this stuff over here is extremely complicated. And typically when we talk about launch lead time, or how long you have to wait before your satellite can actually be launched into space, it's driven by all of these complicated activities. But these are all necessary to get to space operations so that we can actually launch your satellites into orbit. And so just like this, you have to think really hard about deploying small payloads into orbit other than just making things smaller. And so, but that's only the physical part of the access to space. When we talk about accessibility is a very broad term, and it encompasses a lot of different elements. And the physics is just one part of it. However, you also have to be able to afford it. And so when we talk about affordability, we typically look at the launch price, but that's not the whole picture either. And this is very important because if you're a small payload operator, if you're a business that's trying to make money from space, you have to consider the deployment costs of launching your assets into orbit so that you can generate revenue from there. Right now, if you're a small payload operator, you have two options of getting to space. You have dedicated small launch and ride share. Dedicated small launch is effectively the small launch vehicle that can take your satellites into orbit. Ride share is where you hitchhike a ride on a much larger rocket, and you kind of get somewhere close to where you want to go, but not exactly. And so when you compare them side by side, you typically get something like this. But this is not the whole picture. What you really are paying for is all of this. And so when you compare dedicated small launch to ride share, you can clearly see that dedicated small launch does improve the cost of deploying things to orbit a little bit better than a ride share mission. However, the bottom line is this is still not affordable, and therefore it's not accessible to the innovations that we need to make our lives here on Earth better. And so at Aevum, we invented autonomous launch, which pushes this price point and cost of doing business in space even further and makes it affordable for all the great innovations that can improve our lives here on Earth. And this is today. With this unveiling, we are showing the reality of today and what businesses in space will be able to do. However, our mission at Aevum is to make space accessible for everybody, and that includes you. And so we're not going to stop there. This is just the starting point. And as we push further and further and further, autonomous launch will eventually bring down the cost of deploying things to orbit so far down that it'll be literally affordable by anybody. And so naturally you might be wondering, how the heck are you going to do that? With software. All those complicated things that you saw in the previous charts, Aevum took that and replaced it with software. All those people that you saw, all those launch pads, the rocket system, and everything else that I was showing, which encompassed the activities leading up to launch operations, is fully automated with Aevum. And that's what we call autonomous launch. And when we really pull in software into this entire value chain, your logistics complexity really starts to look very, very simple. If you're a payload, you really want to get your payload into Aevum's autonomous logistics network, and then its automated processes take care of the deployment completely so that your end user can download that data, use the images, track things, whatever it needs to be, much faster, and therefore far more cost effective, and then it improves your bottom line, right? So this little bubble here is what we're gonna be talking about now, because a lot of really complicated things happen in that bubble. In fact, it has a name called the Autonomous Launch Architecture. Autonomous Launch Architecture is effectively taking aerospace technologies, combining it with modern tech, and then wrapping all of that with software. And when you do this, you're able to automate a lot of what used to require a lot of people and make things faster and more efficient. Autonomous Launch Architecture is actually a system of systems, and it spans the entire globe, meaning it's not bound to one physical location. In fact, it really has both a digital element and a physical element, which I'll get to a little bit here. But the system of systems has 6 main elements: a worldwide ground station network, cloud services, logistics software and technologies, a worldwide network of spaceports, ground and launch support equipment, and finally, a fleet of autonomous launch vehicles. These 6 elements are all managed by Aevum's autonomous advanced mission management technology. And the advanced mission management technology optimizes all of these assets and makes them work in concert to deliver your mission to success. All this is really complicated, but you really don't have to worry about this as the user. In fact, as a user, you really only need to worry about logging onto our application, and all of these, the entire autonomous launch architecture will be right at your fingertip for use. And we're going to be demoing this in a little bit, but before I get to that, I want to tell you a little bit more about some more aspects of this autonomous launch architecture. So this application is really interesting because unlike software, it actually controls hardware. And so it's going to be a great capability for any businesses and then eventually all of you. So the application that we're going to show is sort of your digital access into the autonomous launch architecture. Your physical access is going to be at one of Aevum's spaceports. This is Cecil Spaceport, Aevum's first commercial spaceport that we established in Jacksonville, Florida in the United States. And over the years, Aevum's going to be rolling out many more spaceports throughout the world because our goal is to be within 24 hours physically of any user of our autonomous launch services without flying. And so if we're going to be physically near everybody. And when you get to these spaceports, it's your physical access into the advanced logistics technologies. And you're going to see a bunch of autonomous launch vehicles like this one. This is Ravn X, Aevum's first autonomous launch vehicle, designed, operated, and made completely in America. Autonomous launch vehicles are comprised of 3 stages. The first stage is a fully autonomous, reusable first stage unmanned aircraft system, a UAS. The second and third stages are rocket stages. The second and third stages are both liquid stages utilizing Jet A and LOX. The first stage also utilizes Jet A. The rocket engines are pump fed and they share the same engine. So it's the exact same engine, both second and third stage, except just some differences for vacuum, etc. The autonomous launch vehicle is a reusable launch vehicle from a regulatory perspective, and it takes off and lands horizontally on a 1 mile long runway, just like an airplane would. And this thing is massive. The gross takeoff weight clocks in right at 55,000 pounds, We have a top speed about 575 miles per hour and a service ceiling of 60,000 feet. And like I said, it's massive. The total length from nose to tail is about 80 feet, has a wingspan of 60 feet and a height of 18 feet. In fact, with the announcement today, the Raven X is the world's largest UAS in the world, in the world database of all military and commercial UASs, which is really, really awesome. So let me show you how this thing works. Raven X is slated to launch payloads for the United States Space Force on the Aslan 45 mission. And this is a simulation, this is an engineering simulation that we performed for the Space Force back in 2019, January. So quite some time ago. We've optimized it a lot since then. But I thought this animation would be really helpful. And so this dark blue line that you see here is the ascent and descent trajectory of the first stage. So that's it going up and then landing. So it climbs to altitude and then performs a stage separation where the rocket stages continue into orbit, which is indicated by this light blue line. And the first stage returns home. And so right now, this little dot is ascending into orbit or altitude. The rocket continues to orbit, and then the first stage lands. It's really that simple. And right there, we just recovered 70% of hardware to be recycled and launched again very, very quickly. So we're bringing reusability right out of the gate for small launch. So we have this animation that actually takes that engineering sim and makes it a little bit more interesting by animating it. And what you're gonna see here is actually the Raven launch vehicle, not the Raven X. There's some subtle differences. And we're gonna be launching 3 Ravens in parallel to lift an entire constellation into orbit at the same time. And I said that correctly. You don't really have to wait to deploy constellations anymore. With autonomous launch, you can just lift them all up at the same time. And so this particular screen is showing the autonomous launch architecture effectively optimizing and executing your desired launch fully automated. And so let's get it going. So autonomous launch vehicles only need a hangar and a 1 mile long runway. So what you just saw there are autonomous launch vehicles just hanging out in a hangar until it's activated. And we don't really need a lot of people to launch autonomous launch vehicles because it is so automated. And so we're initiating mission, and this screen is showing the cartoon of the autonomous launch architecture optimizing the mission and activating the different autonomous launch vehicles. And autonomous launch vehicles are autonomous from the hangar to the runway, all the way to space and back to the hangar, completely on its own. So it takes off like an airplane, and you see the other Ravens sort of queued up in the back there. And it climbs to altitude, and the autonomous launch architecture through our ground station network is already talking to the vehicles the whole time, as well as the different destinations in orbit. And the vehicles are also interconnected. So they're all coordinating all of this in real time and optimizing. So flying around weather and all of these things. And so what you're seeing here is the first stage going to altitude and performing stage separation. So the first stage is now going back home. And then the rocket is continuing into space. So there you saw a second stage separation. And that reference satellite can be a real physical satellite where we're downlinking the actual telemetry of an existing orbital asset, or it can be sort of virtual. We can make one up. And effectively that allows our objective functions to have a target to optimize the entire trajectory around. So right there we just saw a 6U CubeSat deployment cartoon, and the autonomous launch architecture obviously downlinks all the telemetry and shows the status of the missions real time, entire world. And then the first stage returns and lands just like an airplane. It's pretty simple. And then they come back to the hangar, and we're able to go in 180 minutes. So that's how we're going to make space accessible for everybody on Earth. And I'm so excited to show you Raven X today. But before we get to that, I want to recap a few things about autonomous launch. Autonomous launch is 100% safe to human lives. And through automation, we reduce the labor that's required to launch anything to orbit by up to 90%. In fact, the processes are so streamlined that 6 people can launch a Raven X. And right out of the gate, we're over 70% reusable. We only need a 1-mile long runway for launch. We don't need any specialized launch sites. All 3 stages utilize Jet A, which is the same fuel that's utilized by your commercial airliners. In fact, we share the same equipment, which is readily available at most airfields throughout the world. And we can simply fly around weather, and we have very minimal weather dependence, which leads to over 96% availability throughout the year. Meaning, if your commercial airliners are flying, that means Aevum's going to be working hard delivering your payloads to orbit. And through automation, each of our launches are profitable right out of the gate with a high gross margin. And last but not least, autonomous launch has a 180-minute response time to space. Ladies and gentlemen, I am so excited to show you Raven X, the world's first autonomous launch vehicle. Isn't that cool? I really hope you enjoyed that. Welcome back. I just want to take a little bit more of your time and show you a quick demonstration of the application that I referred to earlier. It's going to be a very high level. We're going to try to go through this quick, just spend 5 minutes just kind of walking you through. I really want you guys to have an opportunity to explore this application later. And I want to potentially do a longer video to walk through all the different tools that you have access to through our application. What's really important is that the Space Portal is an interface to our autonomous launch architecture so that it puts the power of that entire architecture, that globally spanning architecture, right at your fingertips. And it's also an interface to our launch vehicle. Autonomous launch vehicles have an interface that you can interact with so that you're not just relying on other people to configure the launch for you, but you can actually take control of that yourself. And so let's just go ahead and start taking a look. So right now, I'm logged on as myself, and currently I'm assigned to the Aslan 45 mission. So this is a dashboard that you might see when you kind of get inside. On the right here, you just see your mission information, when it's going, what mission's active, all those different useful things. And then over to the left, you just kind of have your account information. And then over to the top left, you have the different modes of operations, cybersecurity layers, encryption, and different protocols that are currently active. And that's going to vary depending on the account. So if you're doing a defense mission, you want to make sure that Amelia's mode of operation is in fact in defense mode. And so what we have on the side here, starting from the top, we have a real-time constellation menu where you get to kind of come in and actually try different constellations, and the tool will actually tell you how to deploy the constellation in the best way that you want to, using the autonomous launch architecture and its autonomous launch vehicles. Over on the bottom, you have different autonomous launch vehicles that you can browse, the latest and greatest user's guides associated with the vehicles. Under logistics technologies heading, you have different tools that you can have access to analyze your mission, payload qualification levels, whether you're going to fit within our dynamic envelope. There's a lead time estimator, and then even a terrestrial logistics estimator. That's going to help you figure out how to get your satellite from wherever you are on Earth, to one of our spaceports, depending on when you want to go, how you want to go, and those kind of things. So more on that later. And then you'll have over here under worldwide spaceports, you will be able to browse and kind of look at all of our different spaceports and get access to the mission operations centers that are available at the respective spaceports if you have those permissions on your account. And we're going to spend some time on new space delivery here, but skipping that for now. Managed space deliveries is basically like you're tracking as if you're shipping something with FedEx or something. You just get real-time updates of where you are in the mission activities. Under customer documents, we'll upload documentation for you that's going to be useful, whether it's qualification test reports or something like that. Under space hardware, we have hardware that we have partnered with different original equipment manufacturers to go ahead and certify some of their products to fly on our launch vehicle. So this means that you don't have to go through and analyze your own or play the guessing game of whether some dispenser is going to be fine and compatible for our launch vehicle. If you go and choose some of our supported hardware, then you know that we've already done the legwork and it's gonna work just fine. And so, of course, we support custom. You don't have to use that stuff. Okay, so let's jump over to new space deliveries. You have 3 different options. You have configuration mode 1, configuration mode 2, and intelligent launch. Intelligent launch is something that we're not really going to talk about right now, but it's really going to allow literally anybody that doesn't know anything about space or astrodynamics or rockets to be able to deploy things into space by specifying things like, I want to take a picture of that at this particular time, and we'll just get that done for you. So configuration mode 2, you basically have a custom launch option where you get to specify the spaceport. So right now we have only the Florida spaceports, but we have a couple of others loaded in just for fun and as an example of what you might be able to do. But you can choose your spaceport here. You can choose your launch vehicle and the different mission assurance types. So if you're one of our defense customers, you can choose defense, and then down here we'll display all the different mission assurance activities that we'll do as a part of this mission. So you're configuring this right now. It's all that complex stuff that I showed you in my presentation. It's all automated and simple. So you basically have, okay, Raven X Block 1, this is a defense mission, confirm launch. Okay, so you can basically specify your payload now, containerized, non-containerized, form factor. I want to get to the next step and then I'll stop. You can choose 6U. Let's go with the supported hardware. Let's use a Planetary Systems canisterized satellite dispenser for 6Us. You get all this useful information on the side here. Confirm the payload, and then you can choose the different types of space flight. Single satellite, constellation, on-orbit servicing, satellite replacement, orbital debris removal, responsive. All these are different things that our autonomous launch vehicles can do, and you get to specify that. And then you get to say how you want those things executed. So you choose constellation, and you can say this is a already existing constellation or it's brand new. You can choose your anchor satellite, which is going to either determine your reference true anomaly, or it's just where we're going to start phasing the constellation. You can choose different launch algorithm optimization parameters, so you can maximize performance for reliability, payload. You can maximize payload mass, orbital, or you can optimize for insertion accuracies. There's a lot of stuff here. I mean, you can go a full description of your orbit destinations, so much stuff, and then on step 5, you get to specify your ground logistics and different space delivery options. We have rapid telemetry downlink options. I mean, there's just tons of stuff in here that you can do in mode 2. But we're just gonna skip through a lot of this stuff because I know that we don't have a ton of time today, unfortunately. So configuration mode 1 is basically the available launches. So if you do a custom launch, you can allow other payloads to jump on it, or you can have the whole thing yourself. But doing a custom launch with Aevum doesn't mean that you have to buy the whole capacity. And so mode 1 contains either other custom launches that other customers specified and said, hey, I want to allow other people to ride in with me if it's going to be useful, or these are just launches that Aevum puts out there for whatever reason. And each launch has a different price point, so you can kind of bargain shop, if you will. Check different dates and kind of see which one's going to be the best price. So let's just kind of step through this. So let's just say you're browsing and you're like, okay, I can deal with a 570 kilometer orbit. It's circular, great. This is a good inclination for me, 51.6. And yeah, Ravn X, the flight environment's good. And it's, April 2021 launch. So that's perfect. So I'm gonna select that. And then you're gonna see that, okay, this is a commercial mission. So I'm gonna get commercial mission assurance. Here's the orbit description. Okay, this one's launching out of Florida because that's the only spaceport that we have. Here's the launch window, different optimization IDs. And this means something to our algorithm, by the way. 1 Lima, 10, Mary, 00. Mike, I'm sorry. And so price estimator here is really useful because for this particular manifest, you get to basically choose what you're going to put on it, right? So you use standard form factor with a custom dispenser. Okay, so we're going to choose 6U, and let's just say you have a really gnarly dispenser and it only weighs 3 kilograms. So that's 11 kilogram orbital mass, and that's your launch price on this particular mission. Let's see if we can get a cheaper one. So if you don't mind going a little earlier, right, this month, you select this, you're going to a lower altitude, 35 degrees. That might be pretty significant, actually. So it might not be suitable, but as an example, you can choose the same option, 6U, gnarly dispenser, 3 kilograms, and so you just save some money. So this one's cheaper, for sure. So let's go back to the other one. And I want to demonstrate what happens when you actually launch with us. So choose 6U, 3. And then you get to select your ground logistics. So you can either drop it off at the spaceport in Florida, or you can request a pickup service. So we'll pick up your satellite. So when you go to select ground logistics, you get all this. You get the summary. So when we initiate this, you're going to see. So these screens here is basically the back end of our autonomous launch architecture. And so you'll typically never see this for this particular demonstration. I've just made it available, and so that you can kind of see what's going on. You're going to see the technology optimizing the trajectories. It's going to be running hundreds and hundreds and hundreds of trajectories based on the parameters that you chose, and then it's going to lock in the drop coordinates for a first stage separation. It's going to lock in the different ground station assets that are required based on the trajectory that we just chose. It's going to optimize the ascent algorithm based around the things that you specified that were important to you. That's what that optimization ID was specifying. And it's basically going to activate the different assets. Again, this controls actual hardware. So right now we've got the Ravn X launch vehicle loaded, and it's actually right there. I'm in the hangar, and let's just kind of see how it works. In fact, because I only have so many screens, I'm gonna actually, this would be kind of cool, improv. So we're gonna use a mobile device because again, this is the type of flexibility that is possible. With Aevum. So I'm gonna go to our website. Oh, and I'm gonna log in now. So I'm at the website, I'm logging in. I really should have done this ahead of time. I hope it works. It'd be very embarrassing if it doesn't work. And so we're gonna go to, no, I don't wanna save this password. So we're gonna go, I just selected the April 21 launch, and we're gonna select 6U gnarly 3 kilogram dispenser. And we're gonna drop it off at the spaceport. And we're gonna request space delivery. So this is, Amelia is the name of our architecture software. So we're gonna request space delivery. And Amelia just initiated the launch sequence and just starts optimizing. And so right now the autonomous launch architecture is running through hundreds and hundreds and hundreds of simulations to find the best way to get you to your destination. Remember, this is a 3D space with everything moving. The Earth's moving, orbit's moving, vehicles moving with respect to both. And sometimes it doesn't get a lot, but these were configuration mode 1 missions, so we already know it's gonna work. Hopefully though, Raven X gets activated. So this top right is looking at mass properties, bottom right, performance margins, and then here we're getting drop coordinates. So it's initiating launch. It's gonna activate vision. There it goes. And then yep, so it just aborted, basically, because we have the unveiling demo basically loaded in, set for Amelia to stop the flight. Obviously, we don't want ignition in the hangar. But yeah, typically you would hear that, which gets the all the power systems and everything going, and then we'd get ignition, and we'd run out. But anyways, that was the demo. I hope you enjoyed the rollout of the Raven X autonomous launch vehicle. I'd like to send a special thanks to Colonel Rose for joining us on this special day and being a part of it. I'd like to thank our mission partner on the Aslan 45, the US Space Force, as well as the US Air Force and the Department of Defense. I'd like to thank all of our industry partners, supply chain and vendors, and of course the entire Aevum team. You guys rock, you're awesome. And finally, I'd like to thank all of you for being a part of this special day with us. And I hope you'll tune in for the next step, which is the autonomous flight of the Raven X launch vehicle. And then up next after that is the US Space Force Aslan 45 launch. We're really looking forward to it, and I can't wait to show you the flight. Thanks for tuning in.